Fine. Okay. So let us start. So triple integrals. So I have already explained the triple integrals. We will see some of the applications of it. Okay. So one of the main applications of triple integrals is to find out the volume, right? So in that, note down one problem. Calculate the volume of a solid. Solid bounded by the curves. Bounded by the curves. X is equal to 0, comma y is equal to 0. X equal to 0. Y equal to 0, comma z is equal to 0, and x plus y plus z is equal to a. So can you find out the volume bounded by these curves? So will you be able to solve this problem? Yeah. So a cube by 6 is correct. Now if you notice, this is x-axis and this is y-axis and this is z-axis. Now, so this is one line. So that is what he said was there are three different lines. X is equal to 0. All the three equations, right? So each equation represents a plane. So if it says x is equal to 0, that means that is yz plane. Why? Because x is equal to 0, which indirectly he says that it is independent of y and z. That means y can be any value. So that means every point on this yz plane is part of x is equal to 0 plane, right? The way we say that is x is equal to 0 is nothing straight line y, right? So y-axis is nothing but x is equal to 0 line, and y equal to 0 is nothing but the x-axis. So exactly in the similar manner, in case of 3D, x is equal to 0 represents a plane of yz, not a straight line, right? Similarly, z is equal to 0 is nothing but xy plane, and y equal to 0 is nothing but xz plane. I hope everybody understood that fact. Got it? Right? So here, okay, great. So once you understand that fact, so these curves, we have got three different planes. That is x is equal to 0 plane is nothing but yz plane, and y is equal to 0 means xz plane, and z is equal to 0 means xy plane. So the volume bounded by this plane, and this plane. So these are the planes actually, it is bounding. So rather than imagining here in blackboard, so you try to imagine in the room, so wherein one of the bottom corner, let us say left bottom corner is XYZ origin. Then this is x-axis, that is y-axis, and this is z-axis. Now x is equal to 0 plane means that is the other wall, right? So that wall is x is equal to 0 plane. Now y is equal to 0 plane means this wall, and z is equal to 0 plane means the ground where I am standing. Now these are the three planes actually it is bounding. That means so three corners are bounded now. So this wall, that wall, and the ground. All the three are bounding one particular volume. Now here one part is missing. So in this room, right? So this wall, ground, and this wall is bounding, but another wall is nothing but a plane passing through like this. So this is the plane. So that plane equation is x plus y plus z is equal to a. Now this plane we mean here x plus y plus z is equal to a. To identify the intersection points or the bounding volumes, let us say on x is equal to 0 plane we see. So that is here actually if I want to find out the value of z, keep x is equal to 0 and y is equal to 0. So this is 0 and this is 0. Correspondingly y value is this one, which is nothing but a. So this is 0, 0, a point, this is. And then this point on y, actually if you want to find out, keep y comma z as, x comma z as 0. So that is x is equal to 0 and z is equal to 0. Correspondingly y value is a, this point. So 0 comma a comma 0. Then if you want to find out the value of x where it is intersecting, that is keep y comma z as 0 then x is equal to a. So this is x equal to a. So that means a comma 0 comma 0 is this point. Now the plane binding all these 3 points together, right? So this is the plane what he is talking about. Got it? So there are 4 different walls now. One is the other side wall, another is this wall, another is the ground, and then this is a slanting triangle. So imagine that in the room there is a slanting triangle which touches one of the vertex on the z-axis. So like this, and another vertex is on y-axis and another vertex is on x-axis. So all the 3 vertices are there on all the 3 different axes of coordinate axis. Got it? So, and then this is one corner. This is the shape of a tetrahedron. Got it? Understood? Okay. Now, okay. So now actually I will ask you to give the equations like this. So what is the equation of this particular straight line what I have drawn from this line? So what is the equation of this? What is the equation of that straight line? Yeah, so x plus y is equal to a. That you can derive from this equation. So that is on xy plane I am talking about the straight line. So if it is on xy plane, then z will be 0 in this equation. So this will be x plus y is equal to a. So this is the straight line. Now if I want this equation, then this is y is equal to 0. That means this is x plus z is equal to a line. And if I want this line, that is x is equal to 0, then y plus z is equal to a. This is the straight line. So if you want any straight line on 2D, so you will be able to find out with the help of by making the corresponding value being 0. Alright. So now you wanted to find out the volume of this tetrahedron. So for that you will be using triple integral. So triple integral over the volume be dx, dy, dz. So this is the volume which you wanted to find out. So this volume has to be identified with the corresponding limits. Now these volume limits will be x actually I take as the constant limit. So that is up to you which one you want to take it. Whether you take x or y or z, anything you can take as the constant limits. Depending on that, the upcoming limits has to be coming. So if I make x as the constant limit, x is varying from 0 to a. So this is 0 to a. And then y is varying from, so y is 0 is this x-axis line. And then correspondingly, if I wanted to identify the area on the bottom side, so this is the equation that is binding. So that is x plus y is equal to a is the line that binds at any random point, starting from y is equal to 0. So this will be y is equal to a minus x. So that is on the ground area. You can identify that. So that is y is equal to 0 to y is equal to a minus x. So this is the y limit. The correspondingly the z value if you at any random point if you want to talk about. So this is the z value starting from z is equal to 0 plane, that is upcoming x plus y plus z is equal to a. So this is the plane equation, the z value. That means z is equal to a minus x minus y. So this is the equation of the plane. So at any random point, don't get confused. This is a straight line equation, x plus z is equal to a. But I am talking about the plane. So imagine this way. There is a slanting triangle. So one vertex is so on the z axis. Now on the slanting triangle and so other vertices are on the x axis and y axis. Now within that slant, so you try to draw a straight line from the tails or the ground, then upcoming to the triangle. So that is nothing but the z value. That z value is given by z is equal to a minus x minus y. I hope you understood. So at any point on the xy location on the plane, if you draw upcoming line, that line will give the equation z which is equal to a minus x minus y. So this limit will be z is equal to 0 is the bottom place and upcoming is z is equal to a minus x minus y. So this is dx, dy, dz. So I hope everybody understood this. This is how you have to identify the limits. This is crucial and solving the integral is not big deal. Clear? Any questions? Then you can do the integration dz. So integral 0 to a, integral 0 to a minus x, and then dz upcoming limit, upper limit is a minus x minus y, and then the lower limit is 0. So dx dy. Then if you do the integration with respect to y, so integral 0 to a, and then a minus x into y minus y square by 2, and upper limit is a minus x and lower limit is 0. So this will be integral 0 to a minus x into, so a minus x minus a minus x whole square by 2 into dx. So this will be integral 0 to a, so this is a minus x whole square by 2, then this will be integral of substitution, it will be a square by 6, I think. Got it? Z limit. So Z limit is nothing but, try to imagine the room. So in the room, right, wherever you stand, right? So left bottom corner you imagine as the origin. And then this is one plane, that is one plane, and so ground is one plane. Three different planes are there. Then this tetrahedron shape you are going to get it if there is a slant triangle like this. So that means this slant triangle on z axis it is one vertex, and on x axis it is one vertex, and on y axis it is one vertex. So imagine the room. So just draw a diagonal line from opposite corners, and then this slant is holding on the top. Now here actually, just a minute. Right. So here actually, just imagine. So there is opposite diagonal. Actually, there is a line, and from there actually the diagonal is holding like this, and then so there is a slant triangle like this. So within the room, so below the triangle, you stand there. Then your head will be touching the triangle, right? Correct or not? Middle. So you are located at a random value of x comma y. So there actually if you stand, your head is touching the x, your head is touching the z is equal to a minus x minus y plane. So on this plane, the z value is nothing but given by this plane equation, right? So z is equal to a minus x minus y is the value of z at that particular random location of x comma y. Understood now? So wherever you stand, that is your height here. Okay. So this is about the finding the volume and identifying the limits. Okay. Yeah. So not a simple thing. So I am going to solve for multiple things. So don't worry about that, Sumitra. Got it? So note down this particular shape. Find the volume bounded by the cylinder. Find the volume bounded by the cylinder x square plus y square is equal to 4, and the plane y plus z is equal to 4. X square plus y square is equal to 4, and the plane y plus z is equal to 4, and z is equal to 0. So try to identify the volume first, and then try to find out the integral. Anybody got the idea how to solve this? Anybody else? First you identify the shape. So here, so this shape is x square plus y square is equal to 4. So this is a circle in 2D, but it will be a cylinder in 3D, right? So this circle is of the shape of cylindrical. So this is z axis. I call this as y axis, and I call this as x axis. I am calling that as y axis for the simple reason of convenience. So here he is talking about a plane y plus z is equal to 4. So this is the plane he is talking about. So rather than keeping there, right? So rather than keeping here, if I keep it there, that will be easy for me to draw the graph. So that's why x square plus y square is equal to 4 is nothing but x square plus y square is equal to 2 square. So this is a cylinder with xy plane along z axis. That means this is the cylinder he is talking about. So this is the cylinder. On this cylinder, so this is the cylinder. Now I have cut this cylinder at z is equal to 0 because he is talking about one more plane, z is equal to 0 plane. Then at any instant, so this is the z value, right? So this z value is bounded with y plus z is equal to 4 plane. So when z is equal to 0, then y equal to 4. When y is equal to 0, z equal to 4. The radius of the cylinder is 2. So the radius of the cylinder is 2. And then, so if you draw a slant line like this, so this is the slant line. So here actually, this is 4. Because when y is equal to 0, the z value will be 4. And then when z is equal to 0, the y value will be 4. So this is the plane. So this plane is represented by y plus z is equal to 4. Got it? So this is not a straight line. This is just a cut of the cylinder like this. So along this straight line, I have cut the cylinder. Now what he is talking about is find out the volume bounded by this plane and the cylinder like this. Got it? Now the z value is identified there. Correspondingly, based on the y plus z is equal to 4 plane. And then the area which you need to integrate is this circular area. So this circular area limits will be, so I just write the limits, that is, if you want to find out the volume, so integral dx dy dz over the volume G. And then this will be triple integral. So the constant limits actually for this area, first I will write the limits. So the area is binding with the curve x square plus y square is equal to 2 square. Then this will be, x limits are from minus 2 to plus 2. So this is plus 2 and the other side it will be minus 2. And then y square is equal to 2 square minus x square, or y is equal to plus or minus square root of 2 square minus x square. So minus square root of 2 square minus x square. So upper limit 2 square minus x square under root. And then the z limits are from z is equal to 0 plane is where the cylinder is started. And the upper limit of z is y plus z is equal to 4 plane. That is z equal to 4 minus y. And then z is equal to 0. Dx, dy, dz. So this is the volume for which you need to be integrating it. Got it? Understood or not? Yeah, 16 pi is correct. I hope everybody will be able to solve this. So this is simple integration. So first dz is nothing but z, then it will be upper limit 4 minus y, and then do the integration with respect to y, then 4y minus y square by 2 and substitute these limits, and then whatever it comes integrate with respect to x and then substitute these limits, you are going to get 16 pi. Understood? I hope you will be able to solve, or you want me to solve. Tell me anybody if you wanted me to solve, I will do it, or else we can skip to the next. Anybody wanted me to solve? Yes, so the same thing actually, even if you can write, this is y is equal to minus 2 to y is equal to plus 2, and then this is x is equal to square root of minus square root of 2 square minus y square plus 2 square minus y square, and z value will be as it is 0 to z is equal to y minus 4, then dx, dy, dz. Now here, when you are doing this way, so rather than this dx, dy, dz, you do dz, dx and dy this way. So that means you are doing with respect to Z, then with respect to X, and then with respect to Y. This is also correct, Raj. Understood? Fine. So, any other questions? Okay. Now, yesterday I have explained the rotation of any area will generate a volume. Now, based on that, we will solve some problems. So, I will just briefly explain again. That is, if there is a random shape like this, and then let us say this is x-axis, and if it is rotated like this, about x-axis if it is rotated, then this elemental area, whatever you consider, so this will be having dy and this is dx as the width. Now, if this elemental area is trying to x-axis, it will generate a ring of volume. That ring of volume you can calculate by subtracting this area from the top area like this. So, the cross-sectional view, if you want to identify like this, so this is the cross-sectional area. So, correspondingly, so this is the cross-sectional area, right? Okay. So this area, so for this particular ring, if it is rotated, this is how actually the volume is getting generated, right? So this volume we find out, so this is the value of y. Then from the circle, this is the value of y, and this value is y plus delta y. And then this area, if you want to identify the area first and multiply with delta x, you are going to get the volume. So that is y plus delta y whole square minus y square into delta x. So this is nothing but the elemental volume dV. I hope everybody understood this. Got it? Then this will be y square plus 2y into delta y plus delta y whole square minus y square into delta x or dx. Then this delta y square is 0 and this is cancelled out, 2 pi. Yeah. Sorry, this is pi, yeah. Then this is also pi. Or I will take pi outside. Okay. So then this will be 2 pi y into delta y into dx. So this is nothing but dv. Got it? So this is, so if you integrate this, then you are going to get volume is equal to integral 2 pi y into dy dx. So this is the integral. So this is nothing but the area for which you wanted to find out the rotational volume like this. So if there is any random shape like this, if this random shape is rotated like this, the volume of the generated, so the volume that is getting generated when it is rotated, that volume you will be able to find out with the help of this equation. The same thing you can convert into polar coordinates, that is 2 pi into double integral over the same area, but dy dx is converted into polar coordinates, and then y is also converted into polar coordinates, that is r sin theta into, so dy dx can be r dr d theta. So this is 2 pi times of double integral over the area r square sin theta into dr d theta. So this is the volume in case of polar coordinates if it is getting rotated. This is in case of Cartesian coordinates. Alright. So this is a brief recap of what we have discussed in the previous class. So once you understand this fact, you will be able to find out any kind of shape if it is rotated, then the volume that is getting generated, you will be able to find it out. So understood, or do you have any questions on this? This is rotation about x-axis will be used with y-axis. Suppose if it is rotated about x-axis, then this is the distance actually you need to be talking about. in that case, the same equation, so this is rotation about x-axis. Same equation, if it is rotated about y-axis, then for the same area, so 2 pi x dx dy. Got it? And above? So whether it is y or x is dependent on where it is trying to rotate. Yeah. Okay. I hope it is noted down. So this is rotated like this. If you look at from this side, this is how you are going to get it. So that's what I have drawn this way. Yeah. Calculate by double integration. Calculate by double integration the volume generated by the revolution of the cardioid R is equal to A into 1 minus cos theta about its axis. Can you solve this? Anybody got it? Yeah. So 8 pi a cube by 3. I hope everybody got it. Okay. So let me quickly solve this. See this. So this shape. So this is nothing but the initial line or its own axis. And then when theta equal to 0, then it will be cos 0 will be 1. 1 minus 1 it will be 0. Then R value coming out to be 0. And this shape, so in case of curve tracing also I have explained, this is how actually you are going to get this particular shape. Now the axis of this particular shape is this one. So this is the axis. Now this is rotating about its own axis. Now in that, if you want to find out the volume, you need to consider only half of the volume. So why half of the volume is, if this half of the area, so this half of the area is rotated 360 degrees like this, then even if this half is present or not doesn't matter. Got it or not? So if this present, then actually half the revolution itself will make the complete volume. If this is not present, then actually the complete rotation of 360 degrees for this half of the area will make the complete volume. But the formula whatever we have derived to find out the volume is based on only one part of the shape. That is, so the volume is given by double integral over the area and then 2 pi into r square sin theta dr d theta. Right? So this is the volume that is getting generated as long as if you consider only one half. Got it? So that doesn't matter whether you consider bottom or top, because this is rotated 360 degrees. That's why we have got this. Got it? So here, so these limits are the R value at any random point. R is given by A into 1 minus cos theta. Now this started with 0 degrees and it ended with 180 degrees. That's why this area limits will be integral 0 to pi and then R value, R is equal to 0 to R is equal to A into 1 minus cos theta and then 2 pi times of R square sin theta dr d theta. So you have written R limits inside. To do the integration with respect to R first, integral 0 to pi and then 2 pi you can take it out and then sin theta, then R cube by 3. Upper limit will be A into 1 minus cos theta and lower limit will be 0, and then do the integration with respect to theta once you substitute these limits. So this you are going to get 8 pi a cube by 3. Clear? Any questions, sir? Okay. Solve this problem. Find the volume bounded by the paraboloid x square plus y square is equal to Az. The cylinder x square plus y square is equal to 2ay. X square plus y square is equal to Az. The cylinder x square plus y square is equal to 2ay. 2ay. And the plane z is equal to 0. And the plane z equal to 0. So can you find out the volume bounded by these limits? Try to identify the volume first and then solve it. If you notice, x square plus y square is equal to Az, Hz, it is paraboloid. But x square plus y square is equal to 2ay is a cylinder. So just one letter change made the complete shape different. Anybody got the idea? So let me explain. See this, here the portion x square plus y square is equal to Az. Now this shape, if you notice, this is x square plus y square is equal to a square. Now it is as if like y square is equal to 4ax. So this is a kind of parabola, right? And then x square is equal to 4ay. This is also a parabola. But this parabola y square is equal to 4ax is having x axis as the axis. And x square is equal to 4ay is having y axis as the axis. Now this is the shape of a paraboloid. So this paraboloid shape is nothing but x square plus y square is equal to Az. Now the axis is z axis now. But if you look at from the x side or y side, this is the shape is always the parabola. So the shape is some kind of shape with z axis as the axis. Now if you see from the x axis side, you are going to see the parabola shape. If you see from the y axis side, you are going to see the parabola. But this bowl is located with z axis as the axis. Got it or not? Understood? Everybody? Now, suppose if I make this to z square, then what is the kind of shape you are going to get it? X square plus y square is equal to z square. What is the shape you are going to get it? Can somebody tell me what is the shape? X square plus y square is equal to z square shape. No. Spherical shape is x square plus y square plus z square is equal to a square. That is the spherical shape. So whatever the cross section you see, either it is an xy plane or yz plane or zx plane, it is always a square. X square plus y square is equal to a square, or x square plus z square is equal to a square, or x square plus z square is equal to a square, or y square plus z square is equal to a square. Right? Whatever the direction you see, it is always a circular shape in 2D. So that manipulates to the spherical shape in 3D. But here x square plus y square is equal to z square. This is as if like this way. So this is x axis and this is y axis and then this is z axis. Now here as z is equal to 0, this is x square plus y square is equal to 0, which is nothing but a 0 circle or a circle with 0 radius. That is at this particular point. Now if I keep z is equal to 1, then x square plus y square is equal to 1 square. That is nothing but a circle at z is equal to 1. So here this is the circle of radius 1. At z is equal to 2, it will be circle of radius 3 like 2 like this. So at z is equal to 3, it is the circle of radius 3. Now if I join all these points, this will be like a cone. Got it or not? Right? So this is how actually you have to identify the shapes. So in 3D you have to be quite familiar with the shapes. So some of the random shapes are actually which you can notify easily, that is x square plus y square is equal to az. In this, so there are two squares and another one is only power 1 with some constant. So the constant may be there or may not be there. Z power 1 but x square plus y square, or y square plus z square and this side x, or x square plus z square on this side y. Now all these things are actually the paraboloid shapes only. But only difference is whatever that comes on the right side, it will give the axis of the paraboloid, right? So if it is on the x, then it will be y square plus z square is equal to ax. Then it is a bowl kind of shape, which is nothing but a parabolic shape or the paraboloid shape with x-axis as the axis. Now in this case, z-axis as the axis. But here exactly the same thing, x square plus y square is equal to 2ay. But this is not a paraboloid. Got it or not? Here x square plus y square is equal to az. So it is, instead of a, it is 2a, and this is y. So this made all the difference, right? So this difference is coming into picture just because it is any of this particular variable, any one of this particular variable, then it will manipulate to a cylinder, not a paraboloid. Why? Because I will show you how it is a cylinder. See this, x square plus y square minus 2ay equal to 0. This is x square plus y plus y minus a whole square minus a square equal to 0. So x square plus y minus a whole square is equal to a square. So this is nothing but a cylinder with radius a and located at x is equal to 0 and y is equal to a. Got it or not? Understood? So same thing can't be made for this, obviously, because the other side is a different variable. But if it is 2ax also, it will be the same kind of cylinder, but it is located at a comma 0, right? So based on the location, right? So whether it is y or x or z, x and y leads to a cylinder and z leads to a paraboloid, right? So this is how actually you have to identify. Now let us draw this particular shape. So this is x square plus y square is equal to z, az. So this is z axis and this is x axis and this is y axis. Then it is the shape of a paraboloid like this. So this is the paraboloid. And this paraboloid shape, now there is a cylinder at x square plus y minus a whole square is equal to a square. That means this is a cylinder of radius a and located at x is equal to 0 and y is equal to a. So I call this as y axis rather than x. That will be easy. And then this is at a and then this is 2a. So this is the kind of shape So this is the shape of the cylinder, right? So paraboloid is there and then there is a cylindrical shape is there and these two binds a volume and then there is one more plane, z is equal to 0 plane is this ground plane. So on the ground there is a cylindrical cut. So just imagine this way, there is a cylinder like this and in that cylinder z is equal to 0 there is a cut, a perpendicular cut like this and then at the top actually, so this is extending to till infinite. But there is a cut in a parabolic shape like this. So a parabolic cut is there. Now within this particular bounding limits of z is equal to 0 and this parabolic shape and this cylindrical shape, so there is a volume that is getting enclosed. And this volume actually he asked us to find it out. Understood? Any questions on this identification of volume? Okay, great. Now actually once we identify that limits, then you can use either Cartesian coordinate system or cylindrical coordinate system or spherical coordinate system based on your convenience. So you can solve this volume, right? So let us say, so we use the cylindrical coordinate system because as I told you as a blind rule, if you notice cylinders, then actually try to use cylindrical coordinate system for simplicity. If there are spheres involved, then try to use spherical coordinate system for simplicity. Alright? So that's why if there are circles involved, try to use polar coordinates in 2D. So like this actually, if you change the coordinate system, your work will be very, very simpler. So that's why in this particular case, though you will be able to solve with the help of Cartesian coordinate system, let us use cylindrical coordinate system because there is a cylinder that is involved, right? Now, the shape of the cylinder in case of a polar coordinate system or the cylindrical coordinate system, that is x square plus y square is equal to 2ay. This is the shape in Cartesian coordinate system. Now, the same thing if you convert into the polar coordinates, this will be r square is equal to 2a into r sin theta. So this r will cancel. R is equal to 2a sin theta. This will be the cylinder. This will be a cylinder in case of cylindrical coordinate system. But it will be a circle in case of polar coordinate system. Right? So exactly same thing maps to the cylindrical coordinate system because Z is varying like this. Got it? So this is the shape. Now here, what is this intersection point? So intersection point will be x square plus y square is equal to 2ay. This is the cylinder, and x square plus y square is equal to az. This is the other cylinder. If you want to equate it, you are going to get the relation between these two. So, but in this case, we don't need to find out the intersection point like this. Got it? Now here, this is a cylindrical shape, what we have identified. Now, the polar coordinate system, that is az is equal to x square plus y square, and then az is equal to r square, or z is equal to r square by a is the limit identified by this parabola. So this is z is equal to r square by a. Now here the area is getting identified by this entire circle, and then wherever it intersects, it doesn't matter because actually this is binding the circle there, right? So like this actually if you extend it, this area limits we are writing it, and then to the upper limit, so this z value will be deciding where to go. Got it? Now here the volume, if you want to find it out, triple integral. So here dx dy dz over the volume is converted to cylindrical coordinate system, but r dr d theta into dz comes. So this r will come extra because this is the Jacobian. And then the volume limits are this circle limits. So circle is on the y-axis. So that is on the y-axis. If you notice, usually x-axis is taken as the reference. So that's why this x-axis is from 0 to 5 is the value which you need to be considering as the limits. So 0 to 5. Got it or not? So this theta limits are, theta started with x-axis, that is 0 to 360 degrees, 0 to 180 degrees. I hope nobody has any confusion on this. Theta varying from 0 to 180, not 360, though it is a complete circle. Does anybody have any questions on that? Okay, great. So now actually, so this is 0 to 5, and then R value is varying from 0 to 2a sin theta. And then Z value is varying from Z is equal to 0 plane to Z is equal to R square by a. So R dr d theta, this integral we have to be solving. Now, with respect to dz, if you do it, this integral will be integral 0 to pi, integral 0 to 2a sin theta, and then R, so R into integral dz is z, upper limit is R square by a minus 0. So this is R cube by a. So 1 by a, if you take it out, integral 0 to pi. So R cube by a, integral 0 to 2a sin theta d theta dr. So integral 0 to pi, and then integral r cube. Integral r cube is r power 4 by 4, and then d theta. Upper limit will be 2a sin theta and lower limit will be 0. And then, so 1 by 4a integral 0 to pi. So r power 4 is 2a whole power 4 sin power 4 theta d theta. So this will be 1 by 4a into, so this is 2 power 4 is 16 into a power 4 into, so integral 0 to pi by 2 sin power 4 theta d theta. So integral 0 to pi by 2 I have changed because this is sin power 4 theta. So pi minus theta whole power 4 will again be sin power 4 theta. So we have the principle f of a minus x dx. So f of a minus x is equal to f of x. Then it can be divided into half the limit at the top, and then 2 you have to multiply it. Got it? So based on that principle I have written this way. Now this is a cube, and then 4, then this is 8a cube into, so sin power 4 theta. So sin power 4 theta integral will be 3 into 1 divided by 4 into 2 into pi by 2. So this 8 cancel. So 3 pi a cube by 2. Yeah. Yeah, that's correct. Got it? Any questions on this? Okay, so if there are no other questions, I am going to stop the class for today. So tomorrow I am going to deal with, so any other problems that are left with the triple integrals along with the applications. Got it? So it won't take much of time. I think within 3-4 classes we are going to finish up all, even not even 3-4 classes I think. So hardly 2-3 classes it is going to take to finish this particular syllabus. Clear? Any questions you can let me know. Yeah, or else we can log out. Yeah, thank you. Good night.